start example 3.3, collision of a lump of putty with turntable. So you can see a uniform turntable of mass m, radius r, which is at center O, is at rest in the xy plane and is mounted on a frictionless axle which lies on the z-axis. I throw a lump of putty, which is a small mass, with speed v toward the edge of a turntable. When the putty hits the turntable, it sticks to the edge of the turntable, and the two rotates together with angular speed, which is called omega. So we have to find the angular speed here. So you can see the angular momentum, which is exactly equal to the external torque. Both shows direction, so we have to consider a vector quantity. Further, you can see before collision the torque is 0. It means that the angular momentum remains 0. It conserves. After taking the first order derivative, you will get the angular momentum constant. So, and what does it mean? The angular momentum is conserved. It means that the initial angular momentum and the final angular momentum is equal. So now you have to apply the formula for law of angular momentum, which is this. L equals to the moment arm, or which is called the distance, and multiply the momentum. Okay. So after solving the cross product of these two unit vectors, you will get the angle. Arrange this term. This is the first term and P is another term. We have to express in the form of unit vector. Now further you can see we have to imagine before collision and after collision the motion of this turntable and find out the velocity actually. Now you have to see the angular momentum, which is exactly equal to this r sine theta mv. We can put p mv instead of this p. But then you can see there is a 90-degree angle, so sine 90 is equals to 1. So and r here you can see this is the distance and it is denoted with b. So put the value of b instead of r. Now further you can see this is after collision. After collision we have these angular momentum because both are moving. Okay, so you can see this is the law of inertia, moment of inertia. By using moment of inertia we can write there are two masses. This is the moment of inertia for the turntable and this is the moment of inertia for a point mass, which is actually a putty. Okay, so you can see, and omega, which is angular velocity, remains same. As we know that before and after angular momentum is conserved. Further you can see now we have to compare both the terms. After comparing, and you can see after comparing and putting the value, we will get the actually angular momentum. So you can see this is the value for initial angular momentum, this is the value for final angular momentum. Now arrange the term and take the value of this angular velocity, you will get these terms. So this is the final solution for the angular velocity after collision.